Okay. Camera's like, it's not my fault, dude. This is very true. Okay. All right, is everybody with me here? Okay, so what if we had 16 people who were going to come? How could we represent that? Would I make a full table? Yes. Would I make a full room? No. And again, so let's put it on here. Extra people is 1 each. Each table is 7, right? Each room is 49, and each building is 343. Is this cool? This is the physical idea behind bases and how to keep track of things. So 16 people, will that make a full table? At least one full table? Of course. Will that make a full room? I think we just said, hell no, because you need 49 to make a full room. I like it. Okay. How many full tables was? So do I need to go up to here to represent 16 people? I can't get up to this because I need at least 49 to get something here, right? I don't have any full room, so it's 0. It's empty. I don't have a full room. Now, how many full tables do I have? 2. And how many extra people do I have? 2, right? So 16 in base 10 is 22 in base 7. Crazy shit. Did anybody notice where we started? What was the first number we figured out to write down? Anybody remember what just happened?
The full capacity of the room?
Oh yeah, we sort of started here just to make sure we went far enough to consider. So we couldn't get up to here. And the first number we wrote down was this guy. Which makes sense because I don't know what's left over for the next thing until I do that. Does that make sense? Okay, I like it. So this physical problem explains the math behind how we handle different bases. Math doesn't always have a physical example, unfortunately, right? But very often it does. Okay. Okay, so what if we had, what do you got, Jeff? Let's do 111 people. We got 111 people coming. All right, now, definitely a full table. Am I going to have a full room?
Yes.
Definitely. Am I going to have a full building?
No.
Nope. So I need to go to this place here, right? Mm-hmm. And what makes sense to do to start filling in numbers? Is there any way you can know what goes here immediately? No.
Oh.
Not really. You got to do something, right? So really it makes sense. How many rooms will we fill up completely? 2. How'd you do that?
49 plus 49.
Good, right? I don't know. Did anybody do that? You're like, I did not do 49, put the little division bar, Jeff. I did not do that shit because you don't need to. What? Of course you don't need to. So it would take, so I'm going to have, I don't know. I'm not doing this on purpose, by the way. I'm sorry, just to go with the Tuesday. So 2 rooms are full. How many are left so far? That was 98, right?
13.
Yes. So I got 13 people left over, lucky 13. Does that fill up 2 tables? No, because 2 tables would be 14, yes?
Yeah.
So I got 1 table. And do you understand what's happening? So 2 rooms are full. 2 rooms filled. And now I'm working on the 3rd room. In that 3rd room, I have 1 table full, right? And then how many extra people just to go sit at a table by themselves?
6.
Yeah, because this will be minus 7. So I got 6 left over. Bam. Okay. So, sorry?
Oh, no.
So 111 in our base is 216 base 7. So let me do this. What this says here is that 16, this is the one time I'm going to do this. Base 10, we don't put base 10 normally. I also should write like a little bit bigger. There we go, John. That's the one time I'm ever going to put a 10 down there. Because if we don't put it, of course it means 10, because that's our freaking number, so we don't have to put 10. So 16 base 10, in fact, let me take it over. There, 16 base 10 equals 22 base 7. 111 base 10 equals 216 base 7. Okay.
Yeah.
Is that better? Because what's weird to me is for a while I thought, should I do section 2.3 before 2.2? But then I thought maybe the different symbols would make it interesting and that would lead us into the math for 2.3. But apparently maybe it's better to do 2.3 to do the math, and then we can throw the neat symbols on top. Right? So it's always a question about which one to do first.
You're like, remember these?
Basically. Because of course you got Babylonians. What's Babylonians base number? 60, right? And then we're going to do Mayans, and they have a funky base, right? I like it. So we'll see. Okay. So one last one. You guys do this one real quick. What about if I had, what do you got, Jeff? 346 people. This one should be quick, right? What's going to happen in this situation? Physically, what's going to happen? This one, you almost don't have to do any math, yes? Do you guys see what I'm saying? Yes?
A full building.
A full building
With extra, like,
with 3 people just like out the windows going.
Yeah.
Can't you bring in one more? No. Come on. Okay. You guys kind of, do you see how I could build on this? I could say there's another building. I could say there's 7 buildings, yes?
Yeah.
That would build the next place up. I like it. Okay. Good. All right, now, so let's come back. So now, what was it? I got a little outline for today. But, okay. I think I'm gonna change my mind on this. Yes. No, let's do this. Okay. I have for you, well, you should all be excited. I have for you some weird things. How many people do I have? Okay, I made it up of these. Can you take one of these? Thank you. What the hell are these things? There you go. Anytime. Thank you. I did not whittle these myself, so.
I remember in kindergarten, we had.
You got a good memory. Shit, all I remember from kindergarten was chocolate milk day. Middle of the room. Let's see. Please tell me. All right. I think I made enough of this. Oh shit, you guys need one too, right? There. Oh, I think I'm gonna be okay. No. Am I one short? No, you're good. Okay, you got it. All right, everybody got one, right?
Yeah.
Look at Jeff able to count. All right. Now, do me a favor. Can you, the smallest little blocks?
Yeah.
While I set this up, can you count out 10 of those? And put them on the table. Put them on your desk. What are you trying to tell me? Okay. Oh, yeah. These are so picky, they have to be turned on. Well, I didn't leave any for myself. That's really good. some of you guys understand immediately what's happening here with these bits and pieces. Let's find out. So, let's see, what did I ask you to do? 10? Did I bring 10? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. Okay. So I got 10 pieces here. This is like the number 10. Oh, look at that. Let's see it. Okay. Is this the best way? With what I want is, can you represent this amount using the fewest pieces? Right? So right now I got 10 pieces to represent 10. Can you make it so you have to use less pieces? And do you start to see, what do you start to be able to see? How many, these are called, I went and forgot what they are. These are called longs, these are called flats. Longs, flats, and I don't know, I forget the name of these blocks. And these are obviously cubes, that's great. So how many flats can you make from this? You would consolidate groups of 3, right?
Yeah.
So you can make 3 longs. Yes?
Yep.
Okay, so let me take those out then. So these 3 longs represent these. And I got 1 left over. And of course, this is this. I like it. So there's a 0 here. So what I should have done, if I was really smart, which I am sometimes approximately smart. Let's see. I would have put a piece of paper under here. So what did we end up with here? We got this, this, and this. So we have the 1's place, 3's place, the 9's place. And you can literally see why it's the 9's place now, right? So this is one of these. This is 1 in the 9's place, none in the 3's place, and 1. So this is 1, 0, 1. So the way to represent the number 10, and you can see 1, 9, and 1, 1, of course, right? But where in the process was the division? Where in the process did we do division? Where in what we just physically did we do division?
When we did the 10 singles, how many longs we could fit?
Yes, we grouped, right? The most basic one. Now, of course, division, we're going to learn about it, and we all know what division is, but we're going to learn about the meaning and how to teach it later. But one of the most basic definitions of division is how many groups of this can you make from this amount, right? Which is what we did with the tables. We had a certain number of people, how many groups of 7, how many groups of 7 of 7, 49, how many groups of this can you make? I like it. Okay, so what if you had, you probably don't have enough 1s for this, but let's say I have in base 10, I have 29. Can you make that into, using your manipulatives, so you got 29 of these, right? You can get 29 of these. How would you represent that? How many flats, how many whatever? What's the highest level object that you would have to use? What's a cube represent in this case?
26.
Right? 3 times 3 times 3. I like it. Does it make even more sense now why you start with the biggest thing?
Mm-hmm.
All right. Yes, because if you figure out how much that holds, you can then focus on what's left, and you're certain that there's not too much for the other places. Could I put 4? Would the number 4 ever show up in any place? If I put the number 4 in the 1's place, why is that immediately wrong? Because what does 4 have in it? A 3, right? So what is the biggest number, biggest numeral that we would see in base 3 anywhere? 2. Because the minute you go to 3, it would roll over, right? What's the biggest digit we see in base 10? 9. What's the biggest digit you'll see in base 60? 59. Holy shit. Because the whole idea is once you hit the base, that is the next place over. Right? So a speedometer, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you got no extras and one complete 10. Just like the tables and sitting people. Yes? All right, because, I mean, physically, you could have 8 people at a table, right? But no. Let's say we're in a really strict place. I should have said that. Oh, well. Maybe this breaks down somewhere. It was pretty. Okay, so how do we represent 29 then? Well, we put the places down that we know we need to use. What would the next place be? Well, how did we figure out? How did I get from 1 to 3? Multiply by 3 times 3 times 3. So one more times 3? 81. So that's too much, correct? All right. I like it. I'm just trying to always show you when you're doing this problem on your own, go one step too far. Why do I make you do that? Because sometimes people stop too soon. If you stop here, 9 goes into 29 how many times?
3.
3. Is 3 supposed to exist?
No.
In base 3. I like it. And by the way, is anybody saying to himself, this man is insane because he just wrote a 3 right there. He wrote a 3 right there. Well, why does that not matter? Down here is base 10, so we have some idea what the shit's going on, right? Base 3 is going to show up here, of course, right? None of these could ever be the number 3, because what does the number 3 look like in base 3?
2.
No. What does the number 3 look like in base 3?
It's the next level.
What does the number 10 look like in base 10? I love you guys. You're like, what do you want from me? Well, what does it look like? A 1 and a 0, yes? Yes? Yes, anything. What's the number 3 look like in base 3? 1, 0. What does 1, 0 mean? 0 ones and 1 what?
1.
3, right?
Yeah.
So how do you write 3 in base 3? 1, 0, yes? How do you write 7 in base 7? 1, 0. How do you write 27 in base 27? 1, 0. I love it. Crazy shit. Yes? And I have no idea if we'd still call it 10 if we had 7 fingers somehow. Are you guys semi with me?
Yeah.
That'll really trip you out if you're like, what if we had 7 fingers for some reason, right? You could do it. There it is, Jeff. What if we had 7 fingers? That was a good, I'm showing off. What would our number system more than like, we have no proof that it's because we have 10 fingers, but I feel pretty good that that's why our base is 10. There's nothing magic about the number 10. Except this. That's it. This is the only thing that makes it magic, right? All right, enough of that. Okay. So what would this look like then? 29. What would it look like with the blocks and stuff?
Like 1, 0.
One block, and then what's left over?
0, 0.
Well, there's 2 left over, yes?
Yeah.
And of course, there's 2, so there's no 9s, there's no 3s, your 2s go right there. So this would be 1, 0, 0, 2, base 3. That is what the number 29 would be. So 29 equals 1, 0, 0, 2, base 3. Crazy shit. I'm pretty sure you guys all know binary to some degree. Yes, when I say binary. You guys know what binary is?
1 and 0.
Ones and zeros. The language of what? Computers. And that little weird race in Star Trek. That. Anyway, we won't talk about Star Trek.
Data?
No, not data, but there's a whole race that's spoken binary. Yeah, Jeff, you're a geek. All right. Now, let me push this a little bit. Let me see what you guys think about this. Can you represent, for me, using the blocks and so forth, represent 14. Just take a minute, represent 14 using the blocks. Do it. Some of you guys are like, I'm not going to play with your blocks. Just, it's fine. Play with the blocks. visually, what have you slapped down there?
9.
One flat.
2,
So one what?
One flat.
One flat,
1 long.
one long.
2 long.
Right, what's that so far? It's 9, 12, and then 2 of these. All right, I like it. Now, just keep that there. Keep that there. I'm going to push this a little bit further than we have to go now, just because I feel like it. Keep that there. Yes, we heard you, Jeff. All right, so keep that there. Now represent 7, please. Okay. Somebody else who hasn't told me anything yet, tell me what you did. Yes?
2 longs and then 1 single.
Yeah, exactly. I gotta remember what that is. Hold on. I always forget what they call the little dude. That's too bad for you, Jeff. Here we go. A unit. Oh, cool. Okay, what? That's a unit right there. All right. So there is 7 base 3, yes?
Mhm.
So 14 base 3 is what? 1, 1, 2. And 7 base 3 is 2, 1. Now, what if I ask you, if I just said, add 112 base 3 to 21 base 3, do you understand that would be incredibly freaky? You are not used to that at all. Anybody?
Yeah.
What, if you start to do it, if you start to add these, 2 plus 1 is what?
3.
Which doesn't exist in base 3, yes? So you'd actually put a 0 and carry a 1. Okay. But, can you do it visually?
Yeah.
How would it work if I did this visually? So here, let's start here. So if I add them, physically add them, this is kind of cool, right? You guys see this? So if I do this, what does that immediately do for me?
3.
So I can replace that. Does everybody cool that?
Mhm.
I can replace that with this. That's related to the 0 carry the 1 that I just said, right? There are no singles left, no units. And now what can I do with these guys?
Make a flat.
Yeah, make a flat. Change that out for a flat. Got it. Move them over there. So can somebody tell me now, what is 112 base 3 plus 21 base 3?
210 base 3. 210 base 3.
Oh, there you go. 210. 210 base 3. That's not obvious, is it?
No.
You can't just do this. If I just said, what's 112 plus 21, you should be able to do that in your head, right? But you can't do this in your head nowhere near as quickly because you're not used to base 3. Now, those of you, if you do get an assignment with really small kids who are learning our number system for the first time, they feel the same way you do about base 10, right? They feel as base 10 as you feel about base 3. Do you understand?
Yes.
They've never seen this shit before. They've never seen base 10 before. They are just like you. When we first started talking about different bases, they are in the same place, right? That is one reason, that is the reason really, but that's the reason that we talk about different bases. We talk about different civilizations to kind of put you in their mind frame. All right, here's a freaking Pac-Man means 10. You're like, sure, whatever, dude, right?
Yeah.
I don't know if they're going to go, whatever, teacher. But you never know.
I mean, they do ask like, oh, and then 9 and 10. It's like, why?
Yeah,
Like,
exactly. Oh my God. That is one thing that I would love if more of my students asked more basic questions, but they're gonna, I don't know if they're gonna drive you crazy, because that's the one thing you all know. Anybody have kids? Anybody have kids? Anybody? Anybody ever been around kids? Have you seen them around? Like little people? Do they ask questions?
Yes.
Why? Because. Why? Okay. Sorry. Okay, that's cool. I did more than I thought I was going to. So, when you introduce the idea, let me show you this. When you introduce the idea of base 10, here's what you're going to possibly use to kind of work with it. Because what's one advantage that these manipulatives have? And when introducing an idea like this, over just doing it on the board or a piece of paper, obviously, what does this do for you as a teacher? For students? Huh? The visual, even better though, they are, yeah, they're tactile. They're kinetic, kinesthetic? I forget what else. There's different learning styles. Have you ever heard of those? So it will make a lasting imprint if you can do a visualization of what the hell you're talking about. You can touch what you are talking about. So we aren't often able to touch numbers, right? But there, I am touching 27 right there. I'm touching it, I'm dropping it, I'm eating it. Stop it. Okay. Yeah, you gotta watch it. Now, what you're gonna do, of course, is here's what your flat's gonna look like, right? Because thankfully, you'll be talking about base 10. So here's a flattened base 10. So this is 10. Where's my unit? Here. For some reason, I have nothing but different colors. There's my units. I put 3 of those together, 3 of those. 10 of those together, I get a long. Did I say flat? Here's the flats. That's a unit, a long. I put 10 of these together. I get a flat. And of course, you put 10 of those together, and you get the Borg, right? Anybody get that reference? No. There's a lot of Star Trek happening today. I don't know what. You guys, and you can do exactly the kind of stuff that I just did with you. With base 3, you're going to do the same kind of stuff in base 10. And again, you can touch this. You can make sounds with it. It's awesome. You can maybe get them to stop doing that and focus on the. You never know, right? Hit your head. All right. I like it. Do they want to do anything else with those? And here's the really good question for you. Does base 3 stop at the 20, at this place?
No.
Is there a good way to represent physically the next place up?
Yeah, it would be like, instead of 3 by 3 by 3, it would be 9 by 9 by 9.
No. What's the thing? Every time we step up, physically, this is a little side note, by the way, and I might freak you out, but I just got to talk this now. We start off with something that's like not dimensional at all, just a little point. Then we have, yeah, that's 1 dimension. Then we have 2 dimensions, right? Then we add another dimension, yes? So how would you create physically the next place up? If you figure it out, let me know. You could use, there's something called a hypercube. Have you ever heard of a hypercube? By the way, this is nothing you're ever going to have to teach your kids about, right? Hypercubes. But hypercube is kind of like the best we could do to visualize what a 4th dimensional thing would look like. I'll stop now. That's enough. I'll stop. Okay. Real quick. I can't stop. Won't stop. If I look at this last thing I'll say about this, okay? Don't worry. Dad, do it. If I look at one of these flats, and I look at it like this, doesn't it look like a, yeah, right? Ooh, it's amazing. And if I look at a long and I do the same thing, it would look like a unit, right? So there's an idea about the next dimension down is the shadow of something in the next dimension up. All right, Jeff, that's where I'll stop. This is going to get freaky if I keep going.
Where is the hypercube?
Where is it?
Like, or who's
It's something we've done, graphic, like computer generated kind of idea. It doesn't even show, there's no way to show a 4D thing,
right.
but at least gives you an idea what it could kind of mean. And you can also consider the 4th dimension to be time,
Yeah.
but that's sort of a cop-out. You want to think of it as another physical dimension, which not easy for us to do because the last I checked, we live in 3 dimensions. Or at least 3 dimensions that we can see. I'll stop. Sorry. Okay. I'm not going to suddenly teach string theory. Now, okay, so the purpose for me doing the tables, doing the manipulatives, was to really reinforce why the math we do makes sense, right? So let's come back real quick. You guys can just hold on to those wood pieces for a little bit. Let's look at Babylonian again. Can somebody remind me anything about Babylonian stuff? again?
Goes by 60.
Goes by 60s. I love it. So the base is 60. Zoom. I don't know what that is. Hopefully that's all right. Okay. So you got, so Babylonians, actually called baby. Maybe I'll do the whole thing. There. They have base 60. Okay. What are their symbols that they use? What are their digits? They only have 2 digits. Yeah. They have, yeah, it's really a triangle, but we're going to write it as a 1, and that's the number 1. And what's the other one? Yeah, like a less than symbol. It's like 2 strikes of the chisel together, like bam, bam. To make that, we're going to write like that, and that's 10. And then they had another symbol that's not a digit, but it was basically triangle with triangle. So we're going to write it like this to make it easier. So these are what we're going to write. This is what it would look like on a tablet or something, clay tablet that they would have written on. And this is the idea of minus. Remember that?
Yeah.
Yes.
Is it fine that in the homework we do the minus for some of them?
Is that okay?
Yeah.
Yeah.
Like, can we do the minus?
Of course.
Okay.
Oh, you want to do both? What's that?
No, just one.
Just one. Okay, okay.
Like, is there 2 right answers?
There's 2 right answers. Yeah. Okay, now. So for example, if I had this number in Babylonian, what would that be? Obviously, not obvious. What would that be in ha? Going from baby to ha.
No.
Isn't this 10? This is 10. So how many 10s? I got 2 10s. 20. 33. 23. I like it. What about this here? Yeah, so this is what place. How many places are there here? 2. I like it. This is in the ones place, this is in the 60s. So I've got 160 plus 5 10s, right? Now we finally catch up. 110. Okay, so, yes.
So when there's like a 1 and then like a space, that
Yeah,
represents
dude.
60.
So what really sucks, what if I did this? You just have, there is a space there, right?
Yeah.
Yeah, okay. So what would this number be? So again, if I were you, I'm given this, I would immediately put 1 under there, 60 under there. Good. 10 60s, that's 600, plus 40, 640. And if you were one of the lucky, educated Babylonians, you would look at this and know that it represented the idea of 640. The same way we look at this, and we know that it represents the idea of 640, right? Just like if we would have been taught metric from young, we would understand what the hell a decimeter is. But no, America is special. Okay. Sorry. So, it is always more difficult to go from our system to other systems. Always. For somebody else to us, easy, because it's normally some kind of addition or multiplication and addition. Easy shit. The other way, division, subtraction. Harder. So, what if I had, in Hindu Arabic, what do you got, Jeff? 888. And I want to know what that looks like in Babylonian. So how far up do you have to go? This is too far, right?
Yeah.
Too far. But always go too far. Always go too far and then cross it out. Now, does the math make more sense, what you're supposed to do now? Okay. When we get into 2-3, I'll show you an alternate way to do this. We'll see. So obviously, this would be easier if you have a calculator. But does anyone know how many 60s in 888?
14.
42?
14.
14. Okay, that sounds better. 14. And of course, that would be 840. I really want this to make sense. 14 groups of 60 takes care of 840 of the number, and that leaves over 48. At least 48 left to be taken care of. So if I would have put a 13 here, this would have been 780. How would I know I made a mistake? When I do this right here, what tells me that's a mistake? It's more than 60. It's got another 60 in it. You didn't group enough 60s together. That should be 14. That should be, get out of there, 840, and then I got 48 left over. Okay, and this is not good to circle, right? Don't circle this shit, because this is the middle step. Now we translate it into their numerals. What would 14 look like?
1 Pac-Man, 4 bars. And then 48, would we be able to do a 50
Yes.
and then a -2? That'd be the easier way to
Kick
do it.
ass. Or you could do 4 Pac-Man and 8 sticks. 8 bars, yeah. I like it.
Oh. Let's go to Babylon.
Hmm?
Let's go to Babylon.
A lot of go to Babylon.
Yeah.
Let's take a field trip. Babylonian. Go out to the Fertile Crescent, see what the hell's going on. Okay. So let's finish up 2-2. The only thing we have left in 2-2 is the Mayans. And I told you that the Mayans have beautiful numerical symbols, numerals. Their base is free, right? It's a little free. Okay. So here's what the Mayans are all about. So the Mayans, as I have been teasing, use blueberries. The little dot is 1, and pancakes. That represents 5. That's it. Well, they also have a symbol for 0, so they're a little better than. I can't remember now. I think the book uses. I can't remember. I don't think the book looks like that. That's the symbol I know. What does the book use? It uses a little bit different. I think they just put some lines in there. Let me see. Yeah, there it is. Oh, they turn it around. Sorry, let me do the same as the book does it, and then I'm going to eventually look it up and see what it really is. They do that. That looks like an eyeball with some eyelashes. There's only 2. That's 3. This is 0. So they're one better than Babylonians. They can actually represent a blank space with a symbol, so I don't just have to guess how many blank spaces there are, right? Now, here's their base. Here's the base they use. Mayan base. For one thing that you're really going to appreciate is they wrote their numbers vertically. Just like the Chinese wrote their numbers vertically. At least ancient Chinese, numeration. So their base is based on 20. Their base is based on 20. Sort of. Okay. Ooh, that sounds great. Yay, Jeff. Okay. So they have a ones place, which everybody pretty much needs the ones place. Right? Then obviously the next one, not obviously, but somewhere it's going to break down freaky. The next one is 20. So let's stop there for a second. So an example. If I had this like that, doesn't that look neat?
Yeah.
Can you relatively easily tell how many places there are? There's 2, right? If there was an empty, there wouldn't be an empty space. There would be this. So there's only 2 places, and that's the ones place and the 20s place, right? What does this mean?
6.
Yeah, this is 6 20s plus
2.
2 ones. So 122. Right, is that cool? So it pretty much feels similar. It's got some different symbols, but okay, that's great. Now guess what they did? The next thing, if it truly was 20, a base of 20, the next place should be what? What would it say again? Sorry? 400, right? If it truly was base 20, this is the one place they decided to just go, screw everybody. Are we doing that calendar thing where they'll freak out in 2012? Yes. Let's also do this weird shit with those numbers. Why do you think they do this? They actually make the next place 18 times 20. What is 18 times 20?
360
And again, why is 360 maybe really important for an ancient civilization?
base.
Because the year is about how many days? 360, right? Roughly, right? 360. Y'all with me?
Yeah.
I mean, we got it down to the leap second now, but back then it was roughly 360. So that's why they kind of want that number to show up, because that's a really important number to them. That obviously was given to them by the gods. So you better put it in your freaking number system and they're going to be angry. I don't know if that's the real history. That's the drunk history. That's 360. And then after that, it just continues multiplying by 20. So that's the one hiccup. Forever it's multiplied by 20, except for that one spot. So what is 18 times 20 squared? It'll be 360 times 20, which is 7,200. And then you just keep multiplying by 20. Does everybody understand? I like it. If you don't like it, make a time machine, go back, convince them otherwise. You have to learn Mayan. I don't know where you're going to do that. You have to make a time machine, shit.
Yeah.
But, if you do it, extra credit. I'll give you. I like that. Just show your extra, my math teacher extra credit assignment is to make a time machine. Go convince Mayan. You can do it, come on. Now, so what if I had this number? Let's see. I love the Mayans are some of my favorite ones. So what if I had this? I like that so far.
Yeah.
How many places are there?
4.
4 places. I love it. Right? There's this one, and then there's a 0 place, and then there's a pancake. And then there's a pancake with blueberries on it, right? Exactly how they would describe it. So there's 2 what's up here? 2 7200s. So if I were you, I'd put right next to this is the 1s, this is the 20s, this is the 360s, and this is the 7200s. Right? And then it's multiply and add. It's multiply and add, baby. So you got 0 360s. I got how many 20s?
5.
5 20s. And then I got 9 ones. And now you just got to put that together. Easy peasy. Lemon squeeze. I don't know.
7309.
2 of these, right?
Oh.
144. 45, 145, 09, 145, 09 maybe? Is that what it is? I don't know, that's what I got.
Yeah.
Okay.
Damn.
Niftadelic. Okay. Now, so that way, always easier. Going from somebody's representation to ours is always relatively easier. So what if I had in Hindu Arabic, just in case you don't know, Hindu Arabic, let's see, I've got 512. And I want to take that to Babylonian. What would we do? Where would the good place to start be? So I always think about it like a hangman game.
Yeah.
Hangman game, I do my spaces first. I do the little spaces first, right?
Yeah.
So how many places will we need? I'll definitely need the 1's place. Definitely need the 20's place.
one
360s, and then the next one is, oh shit. Right? It's the same thing, it just goes vertically, who cares? If you wanted to, you could even do your work like this, and then have your answer show up vertically. The middle work, I don't really care too much, as long as I can follow what you're doing, and then your answer has to be correct. Right symbols, right orientation. Yes, maybe?
Yeah.
All right. So do that. I'll sit here and wait. Or I'll stand here and wait. I'll lean here and wait. I'll sleep. Yes?
Is it converted to Babylonians or to Mayans?
I'm sorry.
Oh, okay.
Thanks, guys. I got so used to just saying baby. All right, mine. That's better, Jeff. So where do we start?
360.
All right, 360, I like it. So obviously you just need one of those. All right, so I'm just gonna put a 1 here. So 1, 360. So what do I have left to worry about? 152, is that cool? So now, how many 20s? 7. So now I've got how much left over to worry about? 12. So 12 ones. See, so it's fine in the middle. Isn't that the same exact work?
Yeah.
Just with, slightly different numbers that we did for Babylonians, right? Same middle work. The last step is just bring the right numerals in, right? So how 1 would just be blueberry. What would 7 be? Pancake, 2 blueberries, I like it. And then 12 would be
2 blueberries over 2 pancakes.
good. That's kind of awesome. I like their system, right? Not that I don't like the Babylonians, but I do like the Mayans better. It's too bad. Now I'm going to be haunted by Babylonian ghosts. Great. Good job, John.
The one of The Exorcist.
Oh, yeah. Was that Babylonian?
Sumerian, yeah.
Sumerian, yeah, which is close enough. It's in the same region. I don't want that. No thanks. Okay. Not too bad, right? Is that terrible? I will provide for you the Mayan base, just because I'm a nice person. I will not provide for you the Mayan symbols. You have to memorize those. And same thing with Babylonian. I like it. That shouldn't be too hard of a thing. Okay, I like it. Yeah, let's just keep going. Okay. So, I'm gonna erase all this. What do you think, real quick, all right, here's the one thing, Jeff, I swear to God, I'm like Columbo. One more thing. What if I had to go from Mayan to Babylonian? Yeah, baby. How would you do that? How would you do that? Or would you run screaming from the room? No, come on. Obviously, yes.
Could you convert it to Hindu-Arabic?
There we go, right? You just have the middleman. The middleman is us. Ha! So, what is this? What places are these? This is the 1. So, 20s. 360s. So I got two 360s. Plus
520.
520s. Plus 1. So what is that, 821? Is that right?
Yeah.
So that's 821. And then how do I make that into Babylonian? What are the places in Babylonian numeration system? And this is the one that people are going to freak out. I see people put 360 here, partially because you mix up the math or because you have this in your brain. I understand. But just double check. Every time you do a place system, just make sure. Do it on the calculator, 60 times 60, right? And then 60 times 60 times 60 for the next one, right? So this is obviously too far. So how many 60s in 821?
13.
Yeah, we did that one earlier. 13. That's 780, right? Yeah, 41 left over. 41.
So 4 Pac-Mans, 1 bar.
I like it. So 1 Pac-Man 3, and then 4 Pac-Man 1. So this number in Mayan is this number, or this numeral in Babylonian. They both represent the same idea of amount. Yes?
So for Mayan, since it goes like up and down, it's always gonna be the biggest number at the top?
Yes.
Okay.
I like it.
Awesome.
And I'll say one thing about the Chinese system. I can't remember if I assigned a problem in the homework that dealt with Chinese. Their system is really kind of cool, not just because their symbols are really awesome. I think off the top of my head, I can only remember like 3 symbols, so I'm not going to try to do that. But just really quickly, we're not going to do too much with this, okay? But like this is 2. So 1, 2, 3 are 1, and they have 2, and they have 3. That's nice, and they don't keep going like that, thankfully. 4 is one of my favorite, I think. Let's see, yeah, 4. So this is 2. 4 is, all right, so I mean just no disrespect. I've probably drawn that horribly wrong. I can't see it, to be honest. But it just looked to me like a TV with a show about somebody's feet. I don't know, so hopefully, it just does, I'm sorry. It just is interesting. So this is number 4. Now, don't worry, there's other digits. They basically have a base 10. They use a really neat thing. Let's see, I should remember this. That should be a 10, is that right, Jeff? Did you get that right? Yeah. Yes, I did, look at me go. 10, and then 100. Oh yeah, 100 is really cool. 100 for some reason looks like a beehive to me. Okay, now watch, here's how that works. If I wanted to say 240, Jeff, you forgot the T. 242. So they did this kind of thing. They didn't have a place system. Like if I put 242, how do I know this means 200? Because of the place it's in. How do they know this means 200? Because it's 2 times 100. So that's 200. So their places, they have symbols for their places, or for what we would look at as places. Isn't that kind of cool? So it's a very direct multiplication and addition. Yes?
So do they place their symbols in a specific way, like the Romans did? So would it be like 2 in front of?
Yeah, so it's it really is the digit times the place, and then the digit times the place. And they had some leeway with numbers in the teens where you can write them in different ways and stuff, but
so would the bottom one then be 2 and then 10?
No, this is 200.
Oh, all right.
4T.
410, right?
2.
Right.
Yeah. Okay. Yes.
Quick question. That number above the 60 is 13? Or
Here. Oh yeah, yeah.
okay.
It's trying to be a 13. It's got hopes.
You had shown as a trick of dividing was like whatever was left over, you divide it again, and it'll tell you how much.
Oh, that's right.
So
Yeah,
it's like-
where you multiply, you subtract a whole number away. Yeah.
Because so for example, like here would be,
Let's see. Oh, from here, yeah.
divided by 60, and it'll give you
13 point something. If you subtract 13 and multiply by 60, you'll get 41. Yeah. It's kind of nifty, yes.
Are we allowed to have calculators for the quiz?
No, of course you are. So I will bring some if yours dies or you don't have one today or whatever. I will bring some you can borrow. I like it. But like I said, it's like 14, 15 bucks. You can get one that's got 200 functions on it. It's crazy. And I understand that not everybody, 14 bucks is kind of a stretch. I remember being there myself. So that's why I bring some if you need a calculator to borrow. No worries. Okay. So that is 2-2. 2-2, I don't know if you realize, if you noticed, 2-2's packed. Yes, would you agree with me? 2-2's got a lot going on. It's got Egyptians, Romans, Babylonians, Mayans, and then they hid the Chinese in the homework. Okay, I like it. Okay. By the way, and again, this is ancient Chinese numeration system. They don't really use this too much anymore, except for they're trying to be decorative or something. Now, let's do this. I want to talk a little bit first. There's about our system, Hindu-Arabic. It's obviously base 10. So we have 0 through 9. Those are our digits. It's always got to be one less than the base. But we do end up with how many digits? 10. Okay, I like it. We group things by tens, meaning 10 ones makes a 110, and 10 tens make 100. I mean, all right, basic shit. We know this.
Yeah.
But that's the idea. That's why the division works, because one fundamental definition of division is figuring out how many groups of something, which is exactly how we use number systems, how we use our numeration system. It's place value, correct? Wherever the number is in the, wherever the numeral sits in the full representation tells me what it's worth, right?
Right.
That's what place value or positional value, that's what that means. So like Mayans and Babylonian, they have a place value, positional value system. Blah, blah, blah. And it's additive and it's multiplicative. Nah. Now, here's where we get weird. Let's see if anybody's ever thought of this. What's this number here?
11.
All right. And what's this number here? 12. And what's this number here?
13.
What does 13 mean if you break it down? 13.
Like 10 plus 3.
10 plus 3. You ever thought about it? No? So why isn't this 2-teen? Why isn't this 1-teen? Do you guys follow what I'm saying? Okay. And there's a little bit of interesting history there. It's because 1 through 10 was the most fundamental thing to give names to.
Yeah.
So most places have some digits that have unique names that build into higher level digits. Correct? You guys with me? 11 and 12, some people use 12 as a base. So they wanted to give those their own names also. So 11 and 12 sort of like got wrapped into 1 through 10, and that's like our base system. They each got their own unique name that wasn't built off of something else. 13, of course, was developed later, historically, so it got to be built off of other things that existed already. They wanted, because they're like, holy shit, do you guys realize we're going to go a long ways with these numbers? I don't want to give every single one its own name. Why don't we make a system, everybody? And we're all like, we already did up to 12. Don't worry, we're going to leave up to 12 alone. But now we're going to do a system, right? So 13, 14, 15. Okay, we all know shit. And then what happens after that? How do you say this number? 21, 22, 23, 13, 23. Yes? Now break 23 down. 20, 2 tens, right? 20, 2 tens, 3. 23. So why isn't this, what could I call this then if it was in the same vein as 23, 33, 43? Threes are hard for me. 43, 33, 23.
T3.
Second?
T3.
10T3. Yes? This could have all day long could have been 10T3. Do you guys understand what I'm saying? Anybody? I know some of you guys are like, this dude just said 10T3. What? It's like 11D7. What the shit? All right. Anyway, so again, what the first 20 numbers, like the next ones off of there, this was developed next, and then they realized this wouldn't be quite as easy to keep track of, and that's why everything above 20 has its own kind of repeating idea of how to construct it. So it's just the history of what had to be invented when. And then as they invented shit, they later went, it would have been better to do this. All right, we'll just do this forever, right? Okay, maybe. All right, some stuff you never really thought of. Anybody ever really thought of that? Like 11 is a really exceptionally frequent one. Okay. All right, let me see. That was a little side note. And by the way, as much of a side note as we think this will be really difficult for kids when they're first learning numbers. They want patterns. Humans seek out patterns, and we develop something that has different patterns within it. So when you're a little kid, you're trying to learn this shit, you're like, what the hell were you thinking? Why did you make it like this? Well, it wasn't me. I don't know. All right, I'll stop. Okay.
Yes. I wonder how it varies like across languages.
Oh, yeah. Like I was saying, there's that one civilization that named their numbers based on the body part they were at when they were kind of keeping it
Like joints, right?
up. Yeah. Up one side, down the other side. That is really neat. Off the top of my head, what do you think? I mean, German, a lot of Hindu Arabic was stolen from all kinds of stuff. So our 11 and 12 actually comes from German, which I forget the words. That's kind of like an origin from there that kind of evolved into what we say
From,
11
like
and
the
12.
Germanic language.
Yes. I don't know, off the top of my head, I can't remember anything else interesting about names. I know there's something. Anyway, I'll think about it, because to me, that's always the coolest thing is I'm an English geek as much as a math geek, believe it or not. I love the idea of etymology, of where words came from, why we say things a certain way. A way with words, anybody ever listen to that show, A Way with Words? Not just, I'm a total geek. So that's the marriage of math and words, holy shit, right? But if you know any.
I mean, in France, you pretty much do the same thing up till 17. Like 16 says, like SEIZE, and then 17 is 10, 7, like D7. So.
Oh yeah,
So
that's right.
And then Spanish, we also have like how in French they have onze, we have once, douze, doce, like.
And then tres, quatorze.
Ours goes up till 16.
Yeah. So it's not a similar historical thing between some of these.
Like we say 10-6, 16 for 16.
Yes.
And they say, like their word says, you know.
Yeah, because it's more in French is 21, 22.
Yeah.
Right. So 22, and it matches with their Okay, I love it.
Very true.
Very true. Okay, now, we should take a field trip to France. Maybe in a little bit. Maybe things will relax.
Well, in Tahiti they speak French, so.
What's that?
In Tahiti they speak
Oh yeah,
French.
true. We can
so
go
there.
French Polynesia. We can go all kinds of. We can go to Canada. Hey, why not? Okay. Join the tribes. Okay, that's what I want to do next. So we basically just kind of got into 2-3, and I want to talk specifically about base stuff during. So we did base 3 earlier. Let's do base 8. Let's do base 8. What would base 8 look like? Give me those 4 places. always base to the 0,
8,
base to the first,
64.
base to the second, 512, base to the third. Alright. So, never forget this. If I give you something and ask you to convert it to our system, that's easy. It has to be easy. It must be easy. It just is easy. So if I said, I've got 1, 4, 2, base 8. Can you bring that to base 10? How would you put that back together in base 10? So what I would do is write this out. Underneath it, put the places, right? 1s, 8s, 64s, and now it's easy as shit, right? How many 64s I got? 1. I got 4 8s, that's 32. And then I got 2 1s, that's 2. Right? Let that be easy. Maybe? No? Maybe? Okay. So what I get? I get 98. Is that what I get? Is that right? Did I make a mistake? What happened to everybody? This is weird. Okay. Please let that make complete sense. Yes? No? Maybe? Okay. All right. So from somebody else's to ours almost always involves multiplication, addition. That kicks so much ass. Really easy because the places aren't empty. I know there's a 1 here, a 4 there, and a 2 there, so it's easy to put this back together. If I'm going from base 10, so I want to know what 71 is in base 8. How do I handle that? What do I do first? This should be just like Babylonian Mayan, just easier because we're just using our symbols now. It's exactly the same first step.
Yeah.
What places do I need?
164 and then
1, 8, 64. And obviously the next one's going to be too big, right? Multiply that by 8, that's 512, that's too much. So how many 64s do you use? I use 164. What do I have left? 7. So do I need any of these? Nope. I just need 7 left over. So 71 in base 10 is 107 in base 8. That's neato. I like it. Now, here's where I want you to realize. If I did base 6, before I go too far, is this okay? Is this number okay? Is there anything weird about this number? Is that number okay?
There's a 9.
What's wrong with 9?
It's 2 over where
Exactly. There can't even be an 8 in base 8. Yes? Right? And just to really make sure you understand what I mean, is there a base? Is there a digit 10 in base 10? No. It takes 2 digits to make the number 10, so there is no 10 in base 10. There isn't. It's a 1 and a 0. There's no 10. Okay. There is no spoon. Okay. So that's one thing to realize. So if you do a problem and you get a number that is the base or above, you have done something wrong. Okay, so don't do that.
That's a cutoff, pretty much.
So you,
It's a cutoff.
yeah, cut off, run below. I like that. Yeah, and what it normally means is you didn't divide enough, or like there should really have been a 5 here because some of these bled over to the other place. Okay, I like it. So base 6, the highest numeral we would use would be, of course, 5. So everything's hunky-dory. Let's do it really quick at base 6 real quick. So what if I had, sure, Jeff, why not? 666, and I want to know what that is in base 6. What are the places?
1, 6, 36. 30, no. 21. And then it's 3,600?
Mm-mm.
No.
Multiply by 6 again. I think it's 1296, right?
1296, right?
Maybe, something like that. Okay. And that's obviously too much. And what I want you to realize, I just went to a whole new base, didn't I? Is the work I'm doing really different? No. The work I'm doing is not different at all. I'm figuring out the places, and then I'm going to start dividing and seeing what's left over. The work we do is the same. It's just that if I have a different base, the places are going to be represented by different things, but who cares? It's the same work. How many 216s? 3? Yeah. So 666 minus 648. That's right, 18, thank you. So do I have to use any 36s? No, no 36s. How many 6s? 3, there it is. Because 3 6s is 18. That's neat. That's neat. Did I do that right? Let's see. I wish I could say I thought that out ahead, but I did not. Yeah, there you go, 30, 30. So 30, 30 base 6 is 666. There's something there. There's something there. We're not going to do any more with that. I don't want any demons sprouting up out of the floorboards. Okay. Now, what should trip people out about base, something like base 11? Why should that trip you out? Why should you be like, what the shit? What's the highest single digit in base 11?
9.
10. Yes?
Yeah.
We know this. Well, I was saying earlier, if it's base 27, the highest single digit is 26, and you're all cool with it.
Right.
Right? So same thing. I need to have a single, do we have a single digit base, 10? No. So what we use, the book uses, oh, this book is dumb. Oh, the book is sometimes dumb. For 11, they use E, and for 12, they use T. Sorry. Has anybody ever heard of hexadecimal numbers? They're the ones that identify, for example, one thing they're used for is to identify colors in HTML. So if you want to have each place indicates blue, orange, yellow, red, so forth. So like FFFFF would be white or something if I remember correctly, and 00000 would be black, or the other way around. So to be honest, I might use A and B for 11 and 12. I'm sorry, Jeff. 10 is T, 11 is E. There you go. Change that around. Jumping the gun. So I might use A for 10 and B for 11. And if I do, forgive me, I'm just used to that. This book wants to use T and E. Kind of makes sense. So, what the shit does this mean? If I have a number like 2, 4A, base 11. Let me use their 2, 4T, base 11, right? 240T. What are the places involved?
1.
Ones,
11.
11s,
The 121.
121s, right? And this works the same way. Does everybody understand why there's suddenly a letter involved? Because we don't have a single digit for the number 10. We don't. So we just have to use them. The book uses T. I might use A accidentally because I'm more used to that. So how do I put this together? Same damn way. Same way. This is beautiful. I got 2 121s plus 4 11s plus
10 1.
10 ones. It's the same math. It's the same thing, right? Maybe? Or yes, okay? Yes? Freaked out? So you get 242 plus 44 plus 10 is 296, I think. Crazy sauce.
296.
Yay! God, alright, I know half of your face is hidden, but I still would never want to play poker with most of you guys. I'm looking around like, how are they feeling right now? And I'm getting this. It's not this like this. It's not this like, I'll stop describing you to yourself.
So 240T.
Say again?
240T.
240T, sure. Normally if you're using, you just say 24T,
240.
which sucks. That's why I like A, B, C. It's better, because the T makes it sound like 240, right?
240T.
Anyway, so now that's one reason why ABC is better, because it doesn't sound like something in a number. All right, what about, this is what I was saying earlier, base 16 is hexadecimal, base 16. So I got 0, 1, 2, 3, 9, 10, 11, 12, 13, 14, 15. That's what's used. You can look it up for HTML. You can look up what's the HTML code for colors, and you'll get stuff like blue is BEC39 or something. Yes?
Is this just like just something you're talking about, or is it gonna be like on the quiz?
Totally could be on the quiz, totally could be in the homework.
Okay.
Totally. So, here's where you get nifty shit like this. That now makes sense, mathematically, right? Call me a cab, you're a cab. Oh man, so now I can read some of your faces. Some of you are like, oh god, what this shit. So, base 16, so what place is this? Ones, 16s, 256. So what does C represent?
12.
Yeah, 10, 11, 12. So you got 12 256s plus 10 16s plus 11 ones. Right, C is 12, A is 10, B is 11. So you can get all kinds of really dumb jokes, right? I'm going to try to stay away from some of them.
So
Whatever the hell that is, I don't even want to try to do that.
3,243.
There you go.
Very true.
Extremely trippy. So. Let's see, can you do this, Jeff? Can you do this, Jeff? Give me a second. What is that? Sure. So make that into base 16. We'll see what I just did. I don't know. Try to do something. We'll see if it works. Yeah, you're seeing it. Yeah, okay, I can do that. Yeah, okay. And again, the reason reason why I decided to do 2-2 before 2-3 is 2-2 gets you used to using all kinds of weird symbols. This isn't exceptionally weird. This isn't. This isn't like a Pac-Man. This isn't a pancake. This isn't hot cross bun. The 0 in Mayan looks like a bun. How many 256s?
One.
One of them. And then what do you got left?
167.
167. How many 16s? That's easy. 10. So I'm going to do this right now. This is not an answer. This is my work, correct? Okay.
I have a question.
Yes.
If we put A instead of 10, would that be wrong?
No. Not at all. You're one step ahead of me. My work, I normally use my own numbers so I can kind of know what it means to me, and then at the end I put the symbols back in. But you can immediately make it an A. Where am I? Oh yeah, so 160. So I got 7. So now this will be 1A7. Now one thing good about what you just said is very often I get a mistake. People put this. Okay, why is that wrong? Isn't that 1, 10, and 7?
But it's
But it isn't really. How many places are here actually?
4.
There's 4 places, not 3. Oh shit! So now you got the 1's place, 16's place, 256, whatever the hell the next thing is. Right? That's way too big. Okay, I like it. Now, so the last thing I want to do today is I want to show you a couple of cute kids trying to figure out some math. Right?